Thank you very much. Well, this just to remind us of how we should act during this workshop. Um, and so those of you, well, I won't go through all the bullet points, but you can read it yourself. But what the major ones is, please make sure that your camera is off and your microphone is muted when not speaking. And this session will be recorded. So thank you very much. Well, as I said, welcome to the second half of the workshop. We, the organizer, think the first part, the day on Tuesday, went very well, with more than 50 people attending. We think that's a very good outcome. And we also had some very interesting presentation and lively and interesting discussion, both on the chat and as well as in the discussion part on day one. Well, now I will give you my very personal impression of what we heard and discussed about my notes from the day one. I thought we have some very good presentation that actually triggered why we have this workshop. Then we heard something about how terminology is handled in various places and organizations. That was also very interesting. And we had some presentation on the use of thesauri and ontologies in the work on how to go on with terminology. And from the chat, I had some very, I was also some personal notes that we can the mapping be done between concepts from different organizations and what need to be done, and to ensure that we have the needed nuances between the various concepts and use, and what kind of governance is needed was discussed. If the mapping is done, was discussed during the discussion part of the workshop. And how can URI be handled and governed, and will they be needed when machine-to-machine communication and translation? Most likely. And can notes and example pose a problem if concepts is used cross-domain and cross-organization? That's also some kind of interesting issues that was discussed. And well, for housekeeping, just keep, Richard has showed us what we should do, and now we will go on with the presentation for this day. And the first presentation will be given by Rob Atkinson from OGC. So please, Rob, take it away. Thank you.
Okay, thanks, Jan. Tell me when your screen is shared. Is that visible now?
Yeah, it's visible now.
Okay, so I'm going to go a little bit deeper into some of the broader issues of interoperability specifications, of which terminology is an important part, obviously, and work through a few examples. I'm not going to have much chance to go into any depth, but just to give you a little idea of the breadth of the problem space and where some of the solutions look like they're emerging. I won't claim these things are all solved problems, but at least if we can share where we're up to, we can hopefully find ways to collaborate better. So moving on. Okay, so from the solutions perspective is the terminology harmonization is absolutely important, but it's complementary to what I'm talking about. I'm assuming that something is happening in terms of techniques, and there's a lot more people who are a lot more expert in that than me. But how terminology is actually used during data integration exercises, and particularly the role of interoperability specifications, is where I'm sort of focused. And now I say the real world, but you know, we're all looking at the real world through different abstraction lenses. But in particular, the point here is that we have to deal with both legacy environments and emerging environments. And you know, the perfect solution is not necessarily helpful if it's too far a bridge from where people are at and are able to accept. So a lot of work has been looking at the impact for harmonizing existing and new specifications. And that includes transition paths from various inconsistent or locally relevant specifications and more useful international standards. So I wanted to just explain the motivations for this and show you where the progress was, and then just maybe draw a couple of conclusions about where we may need to collaborate, or where I believe we need to collaborate to move forward. So I'm going to do this in the context of the FAIR principles, which probably most people are fairly familiar with. So I'll provide the sort of this from the perspective of publishing of terminology, and I manage the OGC definition server, and so we've have some principles in place, and I adopted the FAIR principles, and OGC has since sort of taken them on board in a more systematic way. So findable, as far as we're, if like I'm concerned in terms of terminology, that basically means that the terms are web publishable, they're citable, and they're interlinked, which means given one term you can find related things. Accessible, basically, we can resolve the URI. There's no encumbrances for terminology in general, and certainly from the OGC perspective. And the other thing is that we can access it at an individual term level or a collection level. So it doesn't matter how big a set of terms are, you can always find a specific definition. You don't have to download a enormous PDF and then find your way through it. But likewise, if I need to get a bunch of terms for use in a particular application, I can get the whole lot. So that's one of the areas where technical challenges emerge. In terms of interoperability, we use the standard SCOS data model as the framework for sharing terminology. I understand it's not the be all and end all of what we need. More about that later. We've also adopted, in fact, co-developed a sort of standardized API, which has been worked on within the W3C data exchange working group, called content negotiation by profile, which extends content negotiation, which allows you to say, do I want XML or JSON, and actually say, what information model do I actually want? Do I want the SCOS model, or do I want the ISO metadata model, or do I want the WordNet model of a term? And would be the sort of examples. And you still have the basic content negotiation by encoding underneath that, and terminology is available in machine readable forms as well as human readable forms. And the reusability is all around the stability of the URIs and the transparency of the governance. So the way we manage and publish things in one location. And there's a lot of challenges when the OGC is using terminology from other places that haven't necessarily published their terminology using the same principles. That's an area where some work needs to be done. So time is short, I need to run through. Quick typology of interoperability is that there's the technical interoperability, which a lot of the OGC work in the past has been around, which is like APIs and that sort of thing. Then there's a syntactic interoperability. Do we structure these as things the same way? Where we get into the terminology, it's the semantic aspect of it. What does this thing actually mean? But then there's also the levels of organizational interoperability. Is it actually possible for us to share these resources based on who we are and what guarantees we give each other? So all those things need to be dealt with, and they're all important. So when we started looking at the issue of publishing a semantic resource, one of the challenges is to think about who the users are. In the past, a lot of the challenges have been distorted because we've taken it from the perspective of the person publishing the data supplier perspective, because they're the first person to make a decision to implement a standard. But in reality, there's a lot of other players in play in the interoperability space. There's the people developing the standards themselves. There's the people who interpret those standards and say, how do I apply them to my software domain? And here I've just called my application domain. I've just said scientist here, but it could be someone running a business or whatever. And there's a person who actually deploys software, the person who builds the software, the people who actually use that software to collect data, then the people who aggregate that data, store it, the people who expose that via web services, the people who catalog it, the systems of systems that need to interoperate with it, the users, and then these sort of the people who are willing to fund this whole exercise, and the poor old system architect at the back whose brain is full of rubbish at the end of the day, and that's me, I'm afraid. So, given that little sob story, it's the interoperability is not a one-dimensional thing. It's not a matter of just making my data visible using a standard. That tends to not be terribly valuable when there's so many people publishing data and they all use different standards. Another way of looking at this is to look at the types of models and the roles they have in various activities. So this is just a schema of a sort of fairly typical situation where we, in the bottom left, we're taking messages from the field, from sensors, and we have the model role there is simply low bandwidth communications. They're very, very lean. When the data is pulled in from the field, it needs to be transformed. We need to make some statements about what that data means. So we end up having to add metadata to it. So that metadata and the pushing the data into some schema that some data aggregation function is going to use generally requires the application of some of these interoperability standards. But it's not just the domain concepts, and it's not just the general purpose models. Almost always the models are applied, possibly always models are applied to creating a profile of which parts of the model you're going to use and which terminology you're going to use in that model, etc. So you end up with your own little recipe of how you're going to use the model, which is the thing you actually apply. So we can sort of go through that, and there's different types of models, but I guess the point is that, again, interoperability is not a one-size-fits-all, and the role of terminology is sort of pervasive through a range of different functions and layers and different user perspectives. Now, this may be very obvious to most people, but maybe some people don't come from a data integration and interoperability world, and maybe this is useful. So I'm going to look at a case study here, which is around a domain model in the agriculture space. There's a project I'm involved in, IGC is involved in, called Demeter, which is a Horizon 2020 project, has 50-odd pilots. The interesting part of this is that the starting point here was a determination to use a semantics-based approach to modeling the domain model, and with a strong reuse of existing standards. And at that point, the OGC says, okay, right, what can we do to support that? We haven't published a lot of standards as semantic resources. We're learning, and my job is to learn as many lessons and support this project. So now if we start looking at this from a perspective of what are the components of that, there's the big gray blocks, which is the sort of the core, the cross-domain, which are sort of common concepts, and the domain-specific ones. There's sort of metadata standards, and then there's the bunch of standards bunch of things down the bottom, which are the existing activities in the agriculture domain that have published ontologies, and that we need to look at how do we interoperate with those. The OGC is obviously referenced quite heavily in that cross-domain. We develop very general specifications, but how those specifications are actually used by domains is really still a research project, and that's kind of what I'm doing. I'm researching the activity of how standards can be most easily accessed and used. So if we start looking then at the cross-domain model, you can sort of see there's actually a whole bunch of different pieces, and they with a whole bunch of different relationships, and some of these linked to OGC things. And you don't have to go very deep into it. It becomes quite complicated quite quickly. But these are the actual realities. For the real world doesn't generally fit on a convenient slide. We can abstract it out a little bit, and the key point here is to break down into 4 separate concepts and how they interrelate. On the right-hand side, we have the sort of typical terminology SCOS view of the world, and AgriVoc is a vocabulary aggregator and provider that works in the agriculture domain. So that's great. There's a whole bunch of vocabularies over there, terminology sets, and some governance approaches around that. From the Demeter project, we've got a range of different activities and people who are building software and domain and that we want to interoperate with. And we've got the Foodie project, Fireware, which is a protocol for sensor connections and so forth, and Sarafragri, which is another ontology. And there's actually overlaps between these. So the Demeter, if you like, project is actually a profile of which parts of these things are we going to use and how are we going to do terminology mappings between these, so that if someone's coming from the Foodie world, we can link them to someone from the Sarafragri world. And we talked before a lot about terminology mappings. So this is the case where terminology mappings for us is a very operational activity to support data transformations and data integration. And the problem is not one of coming up with the perfect term. The problem is one is actually of describing the relationships of those mappings. And some of those mappings are quite easy to describe, and some of them are quite hard. Anyway, on the left-hand side is the other aspect of it, which is the idea of actually having the components that we're talking about being accessible and reusable. And we're talking about the fairness of the models. So we implement object identifiers under a namespace, which through this w3id.org, which comes out of a community group of W3C, which is the identifier management group. It basically provides a place where we can do a top-level redirection for URIs to the resources that we offer. And so down the bottom, we can sort of see that we may have a resource, which is an agri context JSON file, which can be found there. So those are sort of some of the moving parts. The second part is, we fundamentally what we're doing is we're profiling a range of different standards and then cross-referencing them. And one of the challenges is that when you implement things out there in the world, the semantic model may be the source of your terminology, but the way you package it up tends to be schemas and so forth. And I think it was Heidi on Tuesday who mentioned that one of the interesting issues and challenges was the relationship between conceptual and implementation models. And this is an example of that. So sorry about the text has sort of got a bit carried away with font size there. But so the general idea of taking our model and generating all these different views of that model to support implementations is an area where there are many different things that we may need to do. And if we try to do this manually for the sort of degree of complexity you saw with all the different moving parts, it won't be sustainable, it won't be scalable. So, and now I just want to quickly talk to Ron's talk. So we talked about SMART, as in machine readable specifications, and some of the progress we're moving towards there, and then bring it back to some of those other concerns. So at the moment, the OGC is looking at the use of the Glossarus technology to support the generation of documents from templates using ASCII doc. So we're sort of moving towards a situation where we have a tool chain for bringing standardized terminologies and standardized templates and so forth to create documents. When it comes to data models, though, and the actual the machine readability of the specification content itself, it's unfortunately still separated. So our best practices where we have models in UML, and we can generate schemas and code lists and model documentation objects directly out of those. And then there's other stuff floating around, guidance and examples and conformance tests I should have added to that slide. There's a bunch of different pieces floating around, and trying to find any one of these is actually quite difficult. I have a colleague who's currently working with me, and we're looking to back capture some of the legacy, and just finding all these different these pieces for a specification, even for somebody inside the organization, is it's not a trivial thing. And it's the heterogeneity of those which causes the challenge. Different ways of generating them, different ways of storing them, different ways of accessing them. So what we're moving towards in terms of smarter approach, and I'm working with Nick Carr on this, and we're we're borrowing this from another project that we work on, is taking that OGC document chain and making it driven by a knowledge graph, a semantic model, and basically bringing in sort of specialized templates for different things. So bringing in the schemas and also bringing in example data, alignments. At the bottom, it's driven by the same sort of UML model generating OWL. I have a tool I've got called Profile Wiz, which does all this derivation thing automatically, managing all the Git repository. And the glossalist is something we'll probably look to link into that to say, right, we've got these things, how do we actually refine and improve the documentation at the terminology level? But then when we manage the graph itself, what we have is we have these various different pieces of the puzzle. So on the left-hand side, the orangey bits are the data model side of things, where we have stable standards, we have developing standards, things which we might actually want to put forward as a candidate standard for future. Then we have alignments between the various different models that we need. And then we actually start getting to our domain conceptual model, our logical model, and then the mapping of how our logical model is actually used in different places. And on the right-hand side, we've got a whole bunch of evidence and supporting material, which is not formally part of the model, but it's part of the explanation of what the model does or what it needs to do. And we have use cases and rules. We have the terminology definitions, which have to be included. We have the entities that exist in the language. So we use machine learning to pull some of this sort of stuff out, and example data. So we have these sort of knowledge graphs. And the reason I've laid them out this way is because every one of those little onion rings actually represents a separate governance domain. They're actually being managed, different types of information is being managed by different people in order to make this work. If you build a big soup with all that stuff in, it'll very, very quickly become impossible to scale and manage. So I think I'm just about on track if I've got another few minutes. So just quickly working through just a couple of screenshots. When our documents are coming out, they're coming out now as linked data with, I don't know if you can see it, but basically links to previous other things, the working groups, the conformance classes, which is the entry point to the machine readable view of the specification, etc. So we're starting to build out from just having a list of documents, to list of documents cross-reference to related documents and other pieces of the puzzle. We're also starting to do this for the model elements themselves. So in this case, this is a class from one of the AIM data models from Demeter. And again, it's got all the cross-reference links to all the different things. It's got status information. And on the right-hand side, we can see this is the content negotiation by profile. That thing can be, you can ask that thing and say, right, what options have you got? And then this is the list that you can say, well, I can give you my alternates view, which is this one. I can give you the JSON context for this object. I give the JSON schema. I can give you the whole concept schema it belongs to. I can look at it as an OGC feature type, or I can look at it as an OWL model. I can pull out the class diagrams. I can pull out this as a profile description of how this thing is related to other standards in terms of profiling. So all those different viewpoints are available for the same object. And that's much more scalable because I've only got one object identifier I have to manage, and it's automatically linked to all its representations. So this is the on the left-hand side is a documentation view of all that sort of material, which is actually used to build that other one. So the turtle file behind this is used to build the list of what the links are, and all the different resources which are available and that could be extended now are all linked to the object. So we have a meta model for that, which is a big step forward in terms of
Rob,
being able
1
to.
minute.
Okay, great. I'm just about there. On the right-hand side, this example, that's the JSON context. So very, very quickly, I just want to leave you with a couple of thoughts. One is that JSON is very popular. It's the new XML. I don't know how many people here are aware of this, but in the past, a lot of stuff's been done. But the thing for us collectively to be aware of is that JSON LD, the linked data, is at the top, this business of identifying the context. There's a way of binding the elements in a schema to the URIs, so and hence into the terminology. This is actually quite a major game changer That's quite hard to do with XML, but I think we'll hopefully see a lot of movement towards interoperability and accessibility of terminology. And I believe JSON-LD is a mechanism which will give us that opportunity. So just to summarize, from the findability perspective, we want to make specifications findable from the data as per those links in the JSON-LD. We want to make the individual specification elements themselves cross-reference each other and be findable. And we also want you to be able to start with the terminology in use and find which standards it's in. We want to make it accessible, and the content negotiation by profile means that given a URI, we can find out all the different resources which are available. We want to make it interoperable, and we have a bunch of different data models which we have to standardize, a bunch of different encodings. There's work to be done in terms of interoperability of those between organizations. And we want to make it reusable, which make sure things are modular, and all these different machine readable forms are available. So the next steps that I can see is that obviously the richer ISO metadata model for terminology and SCOS are complementary and can be mapped to each other. So we should be doing some work. We need an ontology for the ISO metadata model, and then we can use the content negotiation by profile, for example, to offer either the ISO view of the world or the SCOS view of the world, or a combined view of the world. So those sort of things are possible. We actually need to start looking at some of the key relationships between specifications and models and terminologies, and actually have some shared ontologies for those. At the moment, I have to make all that stuff up in order to do that in the OGC, but it's not a spatial problem. It's not the OGC's problem, really. It's a great area to collaborate. We need to focus on the conceptual versus implementation relationships that Heidi mentioned before, and that's sort of partly also the class schema terminology. How do those things related? And maybe even some sort of a test bed under the SMART environment, looking at how standards development organizations can actually look at terminology reuse using the FAIR model. So there's a first few obvious things. There's probably a lot of other collaboration areas, and I'd better stop at that point. Thank you very much.
Thank you very much, Rob. Very interesting. Unfortunately, we don't have time for questions right now, so please save your questions for the discussion part of the workshop at the end, and use the chat to have some internal discussions and question raising at that media. So thank you very much, Rob. And I think we are ready for the next presentation, and it should be according to the agenda. It should be Thomas Knudsen from Denmark. Thomas, yes. Are you ready?
Yes, I'm ready.
Thank you very much.
Screen.
Thank you.
Yeah. So there it is, divided by a common language. That's just a moment. Here. This is based on a famous quote by George Bernard Shaw, stating that England and America are two countries divided by a common language. And my main proposition here is that the same can be said about geodesy and geoinformatics. They are two sciences divided by a common language. So this is a case study, really. And I want to start by saying that as exaggeration promotes understanding, what I'll be presenting here will be not many details, because I want to make room for the exaggerations. So this may be a sketchy caricature, but it really is, I think, necessary to give a clear idea of what is actually the problem here that I'm talking about. Let me start by showing a picture of the ideal eternal universe. 2 by 2 units from the lower left corner of the universe, we have this point. And this point is used as origin for a coordinate system by the yellow team of geoinformaticists. they have their geoinformaticists coordinate system here, and at 3.2, 3.2 at the coordinates 3x2 units in their coordinate system, they built their headquarters. But there's a war going on, and the red team of geoinformaticists have set up their own coordinate system, which is slightly offset. So the yellow team's headquarters have different coordinates in the red coordinate system. Actually, it's probably what the real reason they disagree. But you can compute the red coordinates from the yellow. That's the basic thing. So they shouldn't really have to disagree very much. Now, if we zoom in from the entire universe and onto the Earth, things become a bit different. Because if we have a coordinate system that has to cover the entire Earth, the obvious origin to select will be the center of mass of the Earth. And that's what a yellow team of geodesists have been doing. But the origin of their coordinate system is covered by 6,400 kilometers of heavy material. So you cannot just poke a stick into the Earth and say that, well, we have now access to the origin. What you can do is do measurements on the surface of the Earth and then infer the characteristics of a common coordinate system for all those measurements. And that can be done, of course, in an empirical way. And you can do that by the yellow team. And if the red team comes afterward and does the same thing, well, then we get a different coordinate system, which you can see is offset from the original one, not because they disagree with where the origin should be. That should be the Earth's center of mass, but because this geodetic endeavor is really an empirical one, and so things may come out slightly differently, not because the one team has been drunk, not because they are doing their work badly, but because this is empirical. Fortunately, some of the monuments that have been measured by the yellow team has also been measured by the red team, which means we can derive an empirical prediction model for predicting red coordinates from the yellow or the other way around. That's not the case in geoinformatics. Things are not really a prediction, but we can build transformations from knowledge of the internal state of these two different geoinformatics coordinate systems. So knowledge of internal state, I said, well, that could be something like having an owner's workshop manual, in this case for a 50-year-old VW Beetle. Fortunately, I also have another owner's workshop manual for an almost as old vehicle, the NASA Space Shuttle. So once I have the knowledge of internal state of the VW Beetle and the NASA Space Shuttle, well, I can actually derive a transformation from Beetles to shuttles or the other way around. I will probably need to solicit a few spare parts from outside, but I can actually build a shuttle from a Beetle, or at least I can build a set of instruction of how to do it. That is actually the basic way the international standard ISO 19111 of referencing by coordinates has been originally describing coordinates and their transformations. This means that if you need to do transformations, you need to know quite a lot about both automotive mechanics and rocket science. And that is perhaps reflected by the table of contents of ISO 19111, which is rather extensive. There's a lot of terms and definitions and different descriptions of all kinds of stuff here. So in these terms, in the ISO terms, a coordinate reference system is really a real tangible object. It has internal state, it reflects a definition, and for a set of two CRSs, we can infer a transformation between them from these definitions. In the Odyssey, well, it's quite different. A CRS, a coordinate system, is just a label, and there's no axiomatic foundation on which we can build definitions of CRSs. You cannot build a definition of a CRS, but the transformations are the real objects, but fundamentally of empirical nature. So what are the real objects? Is it coordinate systems or is it transformations? This is quite different, but most of the concepts are actually the same. Most of this about the state of the art in the Odyssey is actually reflected in the informative annexes of 19111. So it's not that it's actually surprising that that this is the case. But to reiterate, well, ISO 19111 have a well-defined concept, but it's built on an illusion of an actual axiomatic foundation. Whereas in the Odyssey, geodesists are typically quite sloppy linguistically speaking. So we have sloppy concepts, but they are built on empirical observation and hence do not actually need this axiomatic foundation. And I think the great thing would be to marry geodesy and geoinformatics, which would probably lead to a simplified 19111, which would better be reflecting the real world. And it would also lead to an improved conceptual rigor in geodesy, which I think would be a very good thing. Probably the changes needed are quite small, but that will be another talk for another day. I will just conclude by concluding that geodesy and geoinformatics really are two sciences divided by a common language. So thanks for listening.
Thank you very much, Thomas. And as I said before, we don't have much time for questions, and but I encourage you to write the questions in the chat and the discussion in the chat like we did on Thursday. The next presentation will be one from Alexander Samarin. I suppose you're there. Yes, and so please, the floor is yours.
Sorry, got stuck for a second. Hello, I am a live person, not a chatbot. Okay, I will talk about, sorry, not all windows are moving correctly. Yes, I will be talking about how to create our experience creating concept systems for system domains. I work in several ISO IC committees, and here I'm invited through the IC Strategic Group 12. Okay, so we work with smart city domain, and that is a very complex domain, systems domain, because each smart city people can see from different angles. So there is some kind of structural angle. So I'll take my pen, laser pen. Yeah, structural angles, different aspects, security, perspectives. People would like to see only IT devices or some kind of aggregation. And to describe all this complexity, we following one of the architectural standards. And in this architectural standards, we developed different viewpoints. So what we did, we took a lot of bodies of knowledge and decompose them and compose as we need. And if you look at this, I'm doing very quickly, just to reach terminology questions. In this one of the value viewpoint, you can see there is problem space terminology. That's exactly what I'm going to talk right now. And as you know, in smart city is actually it's one of the domains which using many other domains like digital healthcare, smart buildings, smart energy, smart homes, artificial intelligence, big data. What we found that all these domains, all the system domains, they are developed under different conditions and different assumptions, and they use different terminology. It means that if I need to use big data or IoT in smart cities, I cannot. Because, for example, they use some kind of fundamental concepts different. And this creates a problem because all of this, they are managed as either IEC or GTC1. So how to achieve, how to avoid this? And we know that is a challenge. Okay, all of you from terminology, you know that different people can see the same things from different angles. And they say, yes, they have completely different understanding. As an architect, I have very often to provide this more complex reality view. And our problem is actually, if you boil down to the direct need, that each system domain is very multidisciplinary. Imagine smart cities. And in this case, concept system for the system, for such system domain might be composition of many concepts from many various concept systems from other system domains or subject fields. For example, if you look at our terminology standard, smart cities, so what we have 40 concepts, selected 40 concepts, and one concept must be clarified because we consider city as a system. Then one concept has to be defined because we have to understand what is the meaning of smart city. We have to build common understanding, and all other concepts must be borrowed, but borrowed in the way they don't contradict this majority core concept of our domain. And we need to do this effectively and efficiently. That's the problem. For example, we spent long time, unproportionally long time with this small 40 concepts. And potential solution will be, of course, we use all the theory, we use terminology, ontology, graphs, we use explicit decomposition of all concept system with all explicit ownership. Which group is owned, for example, concept about systems. And of course, we need tooling, externalization. Of course, we have to change things, and even externalization to the international standardization, like this case. In typical situations that we see in this concept domain, we use another concept domain, so that is actually some kind of structure already. And if you borrow some terms, this term could be defined through other terms, as we know, and the conflict may be very deep. And we have to be able to check all this consistency on all the depths. This creates problem because we need to actually backtrace, go to the basics of basics. It's a lot of verification, and ideally it should be done automatically. Unfortunately, we don't have such kind of tool yet. So, as an architect, we would like to do everything, solve problems by design. So it means that upfront, not afterward. So, of course, we need to have the concept systems planar directed acyclic graph, as people told me. Then we need guarantee consistency, we need formal validations, and we have some kind of rules when we borrow a system, when we borrow some kind of terms from existing concept systems. Everything must be versioned, of course, because different concept systems that are designed by different groups, and we have to adapt our terminology rules because they have been designed for slightly isolated standards, and now we have to move to systems work. And what our first step that we are doing right now, we understood that there are several clusters of system domains, and there is some kind of hierarchy of these clusters, and we have selected clusters which we need to handle, and we move some kind of to transversal cluster. We have to define this. We are at the beginning of this journey. We organized several transversal organizations, and our IEC Strategic Group 12 about systems approach in digital transformation, some kind of supervising this activity. Okay, thank you very much. I hope I didn't use all my time.
Thank you very much. Yes, indeed. Actually, you were ahead of time, so thank you very much.
Okay, thanks a lot.
So I suppose, according to the agenda, we should have a 10 minutes break now, so everybody can get some coffee, stretch the leg, get some water or whatever. So I suggest we have a 10 minutes break, which means we will be back at the hour. I won't say exact because it might different time zone. So at the hour we'll be back and reconvene for the continuation of the workshop. So thank you very much. And Reese, could you please put on the slide?
Yes, I will do that. Thanks, Jan. Right.
Thank you. So I think we are ready to start again. And there have been some slight changes in the program because we had just received an apology for one of the presenters in the next block. So the next one will be Anakita Tripathi. Sorry if I didn't pronounce your name right. And then we have Jagadish Budola and Anthony Cooper. Jagadish Budola and Anthony Cooper, you will be given a little bit more time because we have 5 minutes each more because we have the one that was supposed to be a presentation about hydrometeorology and geospatial applications, but that's the one we have just received an apology for. So unfortunately, but I think let's start, and I think I'll give the floor to Anakita Tripathi. So, floor is yours.
Hello, hi, thanks, Jan, for this wonderful introduction. I was also invited because I know a lot of people from this community now, especially Reese, who has been following up with this. So I'll just share my screen. I hope you are able to see my screen. So
yes, fine, thank you.
Thank you so much. So first, I would like to give you an introduction of who am I and what am I doing amongst elite people like you. So my name is Ankita Tripathi. I am a tech writer, and I have been working with the Good Dogs project since the past 1 year. And we have been creating templates for different tech writing problems. We are trying to resolve those problems. And one of those problems was creating and maintaining interoperable glossaries. So we came across this problem in 2019. And since 2020, we have been trying to create processes and templates to subject this problem. From this community as well, I've been working with Reese, Ron, Rob, and different communities of OGC, OSGEO, ISO TC211, and different communities. So while working with them, I understood a lot of problems that these communities have been going through since all these years. So I thought I'll just take this slot of 15-20 minutes and try to explain you what we are trying to do and what are the problems that we are trying to solve. So my agenda for this presentation would be why glossaries, what are the challenges you as communities have been facing, what solution we have as Good Docs team, and what's in it for you. So because we are all here for that. So why glossaries? So first of all, I would like to explain the story behind the Good Docs project. So we are a community of tech writers globally. We are trying to bring a revolution in the way we have presented our documentation of open source projects, or be it glossaries that we are trying to uh, do it right now. So we are creating templates. So to overcome the blank page anxiety that a lot of people or a lot of community members have. So if I want to write something, whenever I open a Google Doc, it has a blank page and I don't know what to start, where to start, and how to start. So we are trying to create those templates, and this is also applicable while creating glossaries for your communities. So whatever terms that you might have, if we are already creating a template, you'll know you just need to fill in it with your details, with your terms. And that's why we are creating these templates. So this year, for Season of Docs, which is a competition kind of a thing where we try to create different templates for open source projects, and that's where I was subjected to creating glossaries. So why glossaries? Why did we even pick this up? So while talking to a lot of community members, we realized that creating interoperable glossaries is one of the biggest challenges for a lot of communities, also because we don't know what terms need to be updated, what terms need to go in, what are the exact definition, what is the style guide that you should use, what are the writing styles that you should incorporate, and all those things. So for a doc, we have just a table of terms. For a project, you have a central repository of terms. For an organization, like if you belong to OSGEO, OGC, ISO TC211 or anything, you need to follow mandate rules. So this is what I've learned over this year also from Reese and everyone else, that whenever you start a definition, you have to start it with just an example, that whenever you need to start a definition for an acronym, you start it with a small letter and not a capitalized letter. So there are a few mandatory rules that you need to follow as an organization when you're trying to explain a term. So while doing that, you need to have a style guide, a maintained style guide as well. So that's also when glossaries need to be maintained. And for cross organization, suppose I'm working with OGC, but I want to incorporate a term from OSGEO. But how do I do that? So only when we agree collaboratively on standards for both the communities or for N communities, that's when we can interoperate within the glossaries. So what are the challenges that we face? The first and the biggest challenge is consistency. So having terms being recognized across different communities is extremely difficult if we want to maintain a small, if you want to maintain the similar standard. There are some preferred terms to use. There is some different sentence structure, like the example that I just gave. There is a different sentence structure for each community. And then there are fields used that are again different. So suppose while working with OSGEO glossary, a part of it last year, I recognized that the fields that we used were acronyms, its definition, one of the examples, one of the use cases. But it's not going to be similar for all the communities. So to maintain that consistency is one of the biggest challenges that we have faced. Second is interoperability, the cross reference to point of truth. So if I want to, again, the same point, if I want to capture a term from a different community, how do I do that? The third part is maintenance, obviously, because we have a lot of processes that go behind creating these glossaries. How do I update those terms? Conflict resolution. If I want to take a term from other community, but I don't know if the same definition applies to my community, how do I maintain it? Version management. So all these problems again occur when it comes to maintenance. The fourth part is tooling. So what tool exactly you should use to create glossaries? Should it be Google Doc? Should it be Excel sheet? Uh, and all those things. So we also have a solution to the tooling part of it right now. And the last part of it is translations. So if I have created the glossary in English, how will a person who is very familiar with Spanish language will understand it? So the translation is another biggest challenge that we have been facing. So suppose there are standard terms that have been used by OGC and ISO communities. So if I want to operate those for my organization, how do I do that? So there is a collection of terms that might overlap. So these were the challenges that we were facing. So we created a solution of how do we do that. So we researched for the best practices, especially for ISO TC211. There has been a style guide that has been maintained over all these years. And while we went through it, we realized it is comprehensive yet extensive. So if we want to capture something from it, that's why we have been creating templates, so that you do not have to go through the style guide, those 15-20 pages of style guide, but instead you can just use the template for your organization and create your own glossary. The second part is we are also going to incorporate standard fields and sentence structures. So again, if you want to incorporate it for your own community, you need not think through that what should be my sentence structure like, what should be my standard field be like. I think there is okay. Yeah, okay. All right. Yeah, so that's what we are also trying to incorporate all these things. How do we do that and all those things? But for this, we also have a new tool, which is called Glossarist, and which is the head of that tool, as we were told, was Ron. And we have known Ron, and we have also used Glossarist for our own purposes. And we realized that maintaining those terms using a tool becomes much more easier. So we have been using all those tools as well. So this is how we imagined it to be. Suppose there is a project A, there is a project B, and I have to incorporate terms from project A and project B. I'll just create a collection of those terms, which can also be created as a subset. So if I have a collection A, I have a collection B, I can also use a part of that collection from B to A and from A to B. So this is how we want to create an organizational glossary, so which is easier for you to understand as well. So the governance of processes, we want to explain that when a community proposes term, and if you want terms from external glossaries as well, we just create a subset of those terms. And then our main purpose remains, where was the source of that reference term that you are proposing? We continuously review those updates. We clean it for a very feasible and understandable language. We resolve overlaps. So if a term is overlapping with another community's term, we resolve those conflicts that happen and maintain those terms over the period of time. So suppose a term has been deprecated, a term has been rejected, is no more in use. So maintaining all those terms and then creating your final glossary. So this is what we have been trying to do with the Good Dogs project. And as a subset of it, we have been using it for Glossaries project. We want to just facilitate clear communication through terms, so that different organizations can manifest the cross-domain glossaries for their own purposes. And that's what we have been doing right now. So I don't know how much clear I was with my presentation. It's my first time explaining it, but I would like to actually see a lot of organizations who are interested in this to participate, to contact us. We have our very active Slack channel where we communicate. We have our weekly meetings where we talk about how can we improve it, and we are in the process of creating this template. So I'm all open to feedback and suggestions from you, because you are the people who have been in this industry for many years. I've just been involved, so I might not be that aware about it, but I would love to hear something from you guys. Thank you so much for this platform, Reese, especially Reese. Thank you so much. So any questions, anything that you would have, I would love to.
Thank you very much. That was a very interesting presentation. And given that we have some time, because we have this, as I mentioned before, this apology, perhaps if someone have a question, so either you can give the question now, or you can save it for the discussion later. But if someone has a question now, please go ahead, raise your hand, and by using the raise your hand facility.
And if anyone needs some pilot details, this is the doc that we have maintained for our pilot details for our project. So if anyone wants to know more about the project, they can just click this link and they'll get to know. So I might have talked a lot with respect to technical writing, because that's what I'm here to do. But from as a part of different organizations, what do you guys feel like? How can we help?
Anyone have a question? Well,
I don't see any questions. Let me just give a remark. Thank you for your presentation. That is really great. I think we need more technical writers, to be honest. I can see that when we write standards, it's experts writing them.
Right.
But I think we're forgetting about users from time to time and forget
Oh,
how
yeah.
they read a standard. So yeah, really, really good job. And we need more people that can actually do this. Yeah, thank you.
Thank you so much. Thank you.
well, I also have one slight question. In one of your slides, you had something about the governance structure.
Yes.
And you had some steering group. If you have cross-organizational work, how do you see the same structure could work for such a group as you have the ISO and OGC, and I think you have one more example in the slides. Could the same structure work for that kind of group as one?
Right. That's an excellent question. So we have been also planning that how do we try to maintain those structures across organization. Suppose if there is a term in OGC that you want to incorporate in your own community, so there should be a slight, the incorporation style should be the same. So what we are working right now is only with the structure part of it. We are still searching for this part of the question that you have just asked, that how do we actually don't resolve those conflicts. So we are still working on that, and hopefully like within next 6 months, that's our plan for the project. We'll have a very good answer for this. So we are working on this.
Thank you very much.
Question from Reed?
Yeah.
Yeah, thank you. Yes, part of the outreach there that the TMG inside of TC211 was doing was to become involved with OSGeo. And so if you're familiar there in the geospatial world, we have our work that we do in ISO TC211 with the geomatics. And there is the OGC group, an industry kind of consortium. And then there is a very long running kind of computing open source software promotion group inside of the geospatial domain called OSGeo. So myself and some other people that are active in TMG, also active in TC211, wanted to engage more with OSGeo. We worked with Ankita, and then we met more of her colleagues from this, the technical writers, people from Google, and these kind of people working on documentation. But we also worked to set up a liaison between the OSGeo group and TC211. And so this has really been, I think it will be more beneficial in the future, but it's been really eye-opening to work with the technical writers and to learn what they need, and that where maybe the definitions and concepts that we're creating inside of ISO might not always be what they require, what they need. And so how do we find a kind of a common ground and those kind of things? So it's very interesting, and I'm very happy that TMG is working to do this, and we hope to continue that work a lot more. And I'm glad Ankita could come and present today to everybody. So yeah, thank you, Ankita. So
Thank you so much, Reese.
yeah, you're welcome. Thank you.
Rob Atkinson, please.
Yeah, I just want to make a comment on governance, and maybe it didn't necessarily come across clearly enough in my talk. I should have maybe looked a little bit more into the governance thing. But one of the principles inherent there was the fact that when a community is actually using a interoperability specification in practice, they're effectively buying into the interpretation of a set of terms to some extent. So if you like, the governance of those is fixed, and there are processes. We have specification working groups and change request procedures and those sort of things. It's not perfect, and often we end up with similar definitions used in different ways and different standards. So the opportunity is to look at improving that by bringing in sort of some of these more formal governance processes for terminology in at the design stage of specifications. But we've also got this general issue that the users will look at a term in context, and that sort of fits into sort of epistemological theory where the community of discourse really determines what something means. And so the challenge for us is having sort of hybrid environments where we've both got legacies and usage and practice, and some of those things grounded in very formal processes, and some of them being less perfect, and also having all the experience of, well, in practice these things aren't defined well enough, or we've used it this way, or all these other different nuances of how people use it also needs to be accommodated. So I think one of the open challenges for us is to actually understand how hybrid governance arrangements are going to work in a federated environment. If we try to come up with a one-size-fits-all process or governance arrangement, I don't think it's going to work. If we don't improve the situation, we end up just getting more mess over time. So there's definitely something we need to do there. And I guess I'm still not hearing proposals for a solution on how we start to bridge that gap.
Thank you very much, Rob. And I totally agree with you that if we don't do something, it becomes more messy. So we need something needs to be done. I think we stop asking questions now and move over to the next presenters, which is Jagadish Budola. If you are ready, please, the floor is yours.
Hello, Reese. Hello.
Yes, hello.
Reese, I can't share my slides.
Sorry about that. There we go.
Okay, now it's fine. We can see it.
Hi, everyone. I'm Jagdish, a PhD student from Indian Institute of Technology, Kanpur. Today, I will present how we are using the shared vocabularies to design the generalization process to derive geospatial data of varying levels of details. So my focus is on generalization part, not on the vocabularies, but I will explain how we used these vocabularies in order to develop the generalization solutions. So the main objective of our work is to design and develop the methodology for automated generalization. For this, we are using open data products from Ordnance Survey. So the source data is corresponding to 1:10K scale. For example, in this case, OS OpenMap local, which is a open data product. So for illustration purposes, I've shown only 3 feature types here: railway, road, and woodland feature types. So the data model of the source data are also shown here. So this is from this data model is from the Ordnance Survey. So as we can see here, road classification type and road railway track classifications are are modeled as code lists in this data model. So our objective is to derive 1:250K representations of 1:10K data through model generalization process. So that is, we need to derive these representations from the source data. So this product is OpenMap local product, and this is a strategy product from Ordnance Survey. So our objective is to go from this scale to this scale, and along with that, we need to modify the data models of 1:250K representation. So before, if we want to go from this scale to this scale, we need to acquire generalization knowledge from various sources. So we try to gain, we try to acquire those knowledge from the data specification documents which are available from various sources. So we referred to many data specification documents from different organizations to acquire generalization knowledge. This figure shows how the data specifications of different data products from different organizations like Ordnance Survey, Geographics, and other national mapping agencies are related to INSPIRE specifications. So as we can see here, Euro boundary map, Euro regional map, and Euro global map data specifications were used to build European spatial data infrastructure data specifications and also European location framework specifications. So again, these ESDN specifications were made in compliance with the INSPIRE, and then ELF specifications which were built from ESDIN as well as from Euro Geographic and other national mapping agency specifications were made in compliance with the INSPIRE. So we also found out that even Ordnance Survey is also trying to release their products in compliance with the INSPIRE. So OS master map projects, which are proprietary products, and OS open products were derived from the OS master map products, and all these products are also moving towards the INSPIRE, means because of the INSPIRE mandate. So as per our objective, the data specifications of Euro regional map and EXM medium scale, as well as OS open data products were useful for us. So is shown is the list of the terms that are defined in the data specifications. So it gives these terms gives information that helps in generalizing the data. So precisely, we looked at these elements in the data specification documents. For example, the constraint, definition, application schemas, and then portrayal criteria and portrayal context and registry, feature catalog. These elements were useful for us to collect the information which was necessary to perform generalization and to develop that knowledge. So the important aspect in acquiring generalization knowledge is to match the feature types of different data models. The matching process gives information about whether the feature is available in the particular scale range or not. So for matching process, we used the definition of the feature type. The other information required for generalization is acquired based on this definition. For example, in the source data, that is Ordnance Survey Open Map Local Product, there is a feature type called a railway track, and the definition of this is shown here. And we also got the geometry information from the data model. So when we looked at the ERM data specifications and we found the feature type railway, even though the name of the feature type is different, but we need to identify the corresponding feature in this data specification. For this, we used definition, and its definition is close to that of the source feature type. So we also got the geometry information here. So the naming is different from the Ordnance Survey data specification to that TRF, but the main linking point was based on the definition of this feature type. So in addition to that, we got the geometry constraint values once we mapped the feature type from both the data models. So we tried to collect whatever information which is available from those specifications. For example, we got this information from a portrayal criteria element. That is, the length of the selection should be not less than 1600 meters. So similarly, we got this selection criteria, like the minimum accepted size, area size. When we go for 1:250K representation is 0.06 kilometers, and the minimum length of an edge is between two connected points should be minimum 50 meters. So this kind of information is very necessary when we perform generalization. So we try to identify this kind of information from different specifications. So similarly, when we refer to EXM medium scale specifications, whose scale range suits our objective, that is 1:250K, the feature definition is shown here, and also the selection criteria. Here we don't have a portrayal criteria information, but the similar kind of information is available in selection criteria. This is similar to that of ERM specification. But in the previous case, the minimum accepted area is 0.06 kilometers, but according to EXM medium scale, it is 0.04 kilometers. So we try to collect whatever the information is available from different data specifications, and we try to acquire those knowledge. So it will help us while developing the algorithms. So at the end of this process, we designed the data model for the target database. As it is seen here, we identified the geometry constraints and the topological constraints that needs to be satisfied by the target database. The code list values, for example, road classification type is a code list value. So from the data specifications as well as from the existing data, we identified that we need to prune that data sets by using these code list values. We need to remove the feature types which are corresponding to these code lists. So we can control the generalization by applying the filters on these constraints, and also we identified the topological constraints which needs to be satisfied in the target database. For example, railway tracks must not overlap with the road, and the railway track must not overlap with the buildings and buildings at other feature types. So similarly, we have designed data models for other feature types also of different themes. For example, buildings, land cover, land use, and all other themes which are similar to that of Inspire in different scale ranges also. So we have identified the type of generalization operation required to transform the source data to the target scale. However, I'm not presenting that part here. because I just want to focus on the modeling part of it. So this is what we have done by making use of the different data specifications from different organizations in order to achieve our objectives. So while I was going through the different specifications, I have one question to the community here. When I go through the European level data product specifications, I see that they are trying to release data in compliance with the INSPIRE specifications. The INSPIRE data models are scale independent. They are designed comprehensive enough to incorporate all the existing data sets of many mapping agencies. So once we get all the data in INSPIRE compliance, according to the INSPIRE compliance, suppose all the data is released in compliance with the INSPIRE, and if anyone wants to derive less detailed data sets with the transform geometry and the attribute information, then my question is, how can we control the code list values when the level of detail changes? So because the existing data model of INSPIRE it contains all the comprehensive list of the code list values. But if we look at the other way, if you want to derive the less detailed data sets from the INSPIRE data model, then how can we control the code list values? So can we have a term that describes these aspects in the data specification documents? Because at present, we don't have any term which describes how we can control the code list values when the level of detail changes. So this is my observation from my study. And these are the references from there. Thank you.
Thank you very much for a very interesting presentation. I think that we save the questions for the general discussion and question session at the very end. So thank you very much.
Thank you.
And I think that Anthony Cooper, you are the next one. And Jagadish Bodo, thank you. Anthony Cooper, I think you're the next one in line. So the floor is yours.
If I can find my presentation. Okay, I'll assume that you can hear me clearly and that you can see my presentation. Otherwise, you'll interrupt me. I don't know
yes,
why.
But yes, to post questions.
I don't know why it insists on showing that rubbish at the top. Anyway, thank you. So mine is, I guess, a much more primitive level of presentation than the others. So I don't even have any UML or anything like that in it. Okay, so in South Africa, we have 11 official languages. Now, most of you will probably be familiar with English. Afrikaans is a language similar to Flemish and Dutch. So English is well resourced, hopefully. Afrikaans is pretty well resourced. But then the other 9 languages are not. So each of the official languages has a national language board. They have a national lexicography unit. And as far as I know, they have all produced dictionaries, updated dictionaries in the last couple of years. But because these languages were poorly served under apartheid and so on, there's a lot of terminology missing. So it's not just technical terminology, but it's also, you know, like names of countries and things like that. And you know, a lot of the emphasis of these language boards and lexicography units has really been at the school level, at the primary school level. First, obviously, and then high school, to make sure that there is terminology that the teachers and students or scholars can use. So it's a way before we can get all our technical concepts in geoinformatics into all of these languages. Now, in addition to these 11 official languages, there are some that the Constitution says should be promoted and create conditions for the development and use of them. So these are not the official languages, they're sort of official. The Khoi, Nama, and San languages, which are of the original inhabitants of Southern Africa. And some of these languages are extinct. So there's several Khoi, Nama, and San languages, but some of them have become extinct. And what do you do with an extinct language? I'm getting all kinds of weird noises. I hope you're not getting them. Then there's also a South African Sign Language, and a dictionary for that was produced quite recently as well. But so these languages are kind of you know, not quite official, so maybe they're not getting the resources they should. But then also the Constitution recognizes that there are many other languages used in the country and that they should be promoted and ensure respect for them. So languages like German, Greek, Gujarati, Hindi, Portuguese, Tamil, Telugu, and Urdu. So we're not going to go and define the German terminology, but, and of course there are many different forms of German and of Portuguese and so on. But when you are defining your terminology, bear in mind that there are people who use these languages who are in countries that you might not think of as homes for people with those languages. And then there are several languages used for religious and other purposes like Arabic, Hebrew, and Sanskrit. But now this is from the Constitution, which is more than 25 years old. And in fact, there are a lot of other languages that are maybe more widely used in some of these. For example, we have large Somalian, Ethiopian communities in South Africa. And of course, we have a huge Zimbabwean community. So there actually are a lot of languages that should be recognized in the Constitution. Now, as Thomas pointed out, there isn't one standard English. So South African English is similar, but not exactly the same as American English, and British English, and Australian English, and so on. So, for example, we have words like earth, which is a land parcel, vlei, which is a vlei, or if you prefer, a wetland, donga, a gully, a koppie, a hill. So those of you who are football fans and know English football will know of the Kop at Anfield and at other fields, and that's named after Spionkop, which was a mountain where there was a lot of British soldiers killed. Then we have robot, which you would know as a traffic light, and the reason it's called a robot is when the first traffic lights were put into Johannesburg, that famous play which introduced the concept of a robot was on, and so the name was obviously applied to these funny blinking lights. Then there are legal concepts, which obviously depend on your legislation. And so we have a principal traditional community, which is defined in the legislation dealing with traditional communities. So that's a concept that would be completely meaningless in another country, although they might have a similar kind of concept. And then we have load shedding. So load shedding is scheduled rolling blackouts because the electricity supply system is in poor condition. And I mention it because we've had load shedding this week, but fortunately it stopped before now, because otherwise I would be in load shedding at the moment. Okay, so a bit of background. We have the Spatial Data Infrastructure Act, which was passed in 2003, but not much happened until 2010. But it set up, well, it provided the framework for setting up the South African spatial data infrastructure, and it established the Committee for Spatial Information. Unfortunately, the committee isn't functioning at the moment because its term ended in January and the relevant minister hasn't appointed the new committee. But we are carrying on informally. So it has several subcommittees. And the one that's relevant here is on standards. So the first thing is to prioritize standards, because as we were told yesterday, there are over 80 standards in ISO TC211, and no one's going to adopt them all at once immediately, and has to prioritize them. Because one has to understand them before you can implement them. And one has to actually get them. So ISO standards are astonishingly expensive, even if they cost $1. The bureaucracy that one has to go through in a government department or a municipality or something is high. So that raises the cost of having to buy something. So within the CSI, we have a process to procure the standards for the data custodians. So a number of ISO TC211 standards were procured, although of course it was the South African edition of them. And we would now like to get on to procuring more standards for the data custodians. The problem is, because of bureaucracy, because of legislation, because of corruption, there is a lot of red tape over procuring standards. And so because there's only one supplier of the standards in the country, you know, you can't go out to open tender. And then because the bean counters in the department and the bean counters in the SABS don't quite understand this, it has taken a few years to actually try and procure a few more standards. And then training, you'll see there's an education and training subcommittee, but obviously we need to direct some of the training towards standards. So most of it has been aimed at the metadata standard, ISO 19115. And then what's obviously of relevance here is terminology. There are a few other things. Now, I'm not going to go into the terminology of the CSI itself. I'm just going into terminology in general. So as I mentioned, these lexicography units are developing terminology for many different fields, starting at the school level and then moving up to higher education. So these are just some examples of what is happening. So you'll see the first a column of terms are for a bank, as in where you put your money, not a bank of a river. And you'll see that the terms look largely similar, although Setswana has two quite different terms, so they come from quite different roots. And that is one of the problems with terminology, is how do you create a new term if that term doesn't exist in the language? Is there an existing concept that can be adapted, or do you take, say, like here, ibanki, which is taking the word bank from English or Afrikaans, and then adapting it into that particular language's structure. And so adding the I makes it a noun. And then you'll see here for heavy manufacturing industry, you get a whole lot of different structures for the terms. So you see here we have one where it's reduced to 2 words, but here you'll see it's reduced, it's 1, 2, 3, 4, 5, 6, 7 words. So it can be quite complicated to create terminology in multiple languages. Then you see here a market, as in a marketplace. Again, they're largely similar. But you can see all of these languages here, which are closely related. You see Zulu, you see Xhosa, you see Swati, you see Ndebele, and I see I made a mistake here that I shouldn't be at the end there. Apologies. They are similar in their languages, and you'll see they all start with an I. So it's one of the terminology problems you have is how do you sort words where all your nouns start with the same letter, because that's the prefix that specifies the kind of letter rather than having it as a suffix or something. And then here we have a stock exchange. And again, you can see quite a variety of ways of translating or creating that term in other languages.
Anthony, 1 minute left.
Thank you. Okay, so I think this is my last slide, actually. So here we have satellite dish. And so you can see I made an attempt here with these numbers as the different kind of style of creating the word. So in English, a satellite dish or a dish are synonyms, and in Afrikaans, satellietskotel or skotel. So you'll see isiZulu takes it from the English dish, whereas you'll find Setswana here takes it from the skotel, and Sesotho also from the skotel. Okay, and where there's a 0, those are the ones where I'm too stupid to work out the root. But you can see these two are have some correlation, but they're two different words for the same concept. So that obviously makes it quite difficult to create terminology. Thank you.
Thank you, Anthony. That was actually very fascinating with all these languages that you have to cope with in your language in South Africa. Now we have a 10 minutes break before we go to the discussion and question part of this workshop. So I propose that we will be back again by the hour, which means not 10 minutes, but only 9 minutes. But still, let's be back by the hour and have the discussion and question part. So see you in 9 minutes time. Thank you. Hello, everybody. I hope you had a good break, got some coffee or water or whatever you needed. Now I think we are ready for the last leg of this workshop. And As you might see on the agenda, it's some discussion part we now have for the almost the next hour, at least next 50 minutes. And that will be led by Heidi. So I will give the floor to you, Heidi.
Yes, thank you, Jan. I would suggest we start by giving you all the opportunity to ask questions, both on the presentations we've seen today, but I think about half of the presenters that were there last Tuesday are also present. So please let's have some time for questions on the very good presentations we saw. Please raise your hands if you want to ask. No questions? Then perhaps Erik Stupkjær, we've been communicating a bit via mail. Would you perhaps like to clarify a bit of your presentation or ask the questions you have for the terminology community? So perhaps we can come a bit closer into that topic. Would that be okay with you?
Okay, thank you very much. My question more or less is where to start. We have the code list problem, and I was informed that somebody had commented in the chat on this issue. Unfortunately, I have not been able to check the chat list, so I do not know what was commented upon. So maybe I would ask participants whether they have commented in the chat list and what were their questions or comments. Thank you.
Two hands raised. Sorry, I didn't see who was first. Rob Atkinson, please.
Even though I'm sort of familiar with Calithay and I've helped publish both of these things and definitions over, I don't fully understand exactly what the issue or the problem is. To be honest, I think there is an issue that we see around soft typing versus hard typing that I think that Jagdish was also coming to, which is sometimes we have an animal of type cat and sometimes we have a cat. Sometimes cat is a code list and sometimes cat is a model class, and different people, different groups will often choose to stop their modeling and move to categorizations in different places. The mapping between an animal of type cat and a cat object in a different, I mean, that's actually a tricky problem that it's not obvious how to standardize that. So I'm just wondering, where, exactly what your problem is, but to the broader community, how do they see the relationships between models and instances or categorizations being done? Is there a canonical approach that we should all be using when we actually publish terminology, in particular, definitions of categories?
Sorry, I have technical problems. Where am I? Yeah, I am. Well, it seems it's a hard problem then. When I talk about code list, I use the context of UML modeling, which has a category for code list, and I use the code list term as it is defined in the standards, both from the ISO side and from the OGC side. And my first concern is not so much the values of the code list, because the meaning of the code list and their values is defined by the standards, while I would be concerned of the concept of the calated thesaurus and their definitions, I take the code list and their values as something given that I need to reflect only as far as I represent the code list value in the thesaurus. So this is my approach to the meaning of code list and code list values. I wonder whether this is a kind of answer or comment to your question.
So if I can characterize that correctly, one of the issues here, and this relates to the general issue I was raising, which is that in this case, code lists are a matter of they have their own distinct governance domains. So that when you're modeling in this case, your terminology, your taxonomy, the code lists are immutable because you're bringing them in from a separate governance domain and you have to reference them. So that's one typical problem, which is that, like I mentioned before, it's the fact that our actual semantic resources require hybrid governance models. And I think that's a good example of it. And I think the second issue is the canonical linkage between model elements and related code lists and how that should be expressed. And the only ontology I know that actually provides a way of doing that is a thing called RDF data cube, which allows you to express a dimension in terms of what element, how a range is mapped to a concept scheme or a code list. There does seem to be that's slightly obscure for many people. There doesn't seem to be an easy way of mapping code lists to concepts in a systematic way. If there is, I'd love to hear about it.
Mm-hmm. The reason that we would like to relate code list to concepts is that land administration domain model is not has no encoding, and therefore people and national specialists have to provide a profile, and in order to reduce the complexity of these profiles, in order to have more common profiles across countries and nations, the LADM people invited us or welcomed us when we added the code list to the thesaurus, so that the thesaurus could work as a communication, mediating platform, as put it. But I noticed in this morning the presentation from India. In your presentation, you mentioned also that you are using code list and the recording of code list. If you do that in a SCOS context, that your experiences and your practices could be interesting. Maybe you have a comment on that.
Hello.
Yes, we hear you.
Yes.
Yeah. Yeah.
Actually, I'm trying to use the code list. We are targeting to generalize not just the geometry. We also want to give the database which contains the abstract information from the detailed one. So when we have a abstract detailed database where different level of hierarchical code list information is available, where we have information from country level to the local administration level. But if you want to derive data product which gives information only about the country level, not about the local administration level, so we need to remove the lower part of the hierarchy. So we don't know how to control those things. Is there any standard way so that we can cut off, say, so below part of the hierarchy? For example, if you are going from 1:10K to 1:25K, so if you have if the height of the tree, code listed tree is 3, then we reduce it to 2 or 1. So I don't know I'm making sense or not. So because we don't want to give complete attribute information to the user. Instead, we need to control the attribute information also along with the geometry information when we derive abstract data products. So that was our objective. So I posed those questions because if we provide any standard way or something, some guidelines or something, so that we can follow those guidelines, standard guidelines in Indian context or some other country context. Thank you.
Thank you very much. Thank you. I think we should go. I'm prepared to go on discussing this by mail. Thank you.
Yes, Peter Parslow.
Thank you, Heidi. We had Jagdish and I had a conversation which was visible to others in the chat, as well as a little bit of private conversation around code lists. And it raised initially because I was encouraged to see OS Open Map Local being used in his work and presentation because I was involved with the team who made it. But on the point of code lists, as Rob has said, using a code list as a way of classifying the data is, in a sense, the same thing as using a hierarchy of types. So they're both issues around mapping between concepts that have come from different domains. In Jagdish's case, he's talking about generalization. So the specific issue is not so hard to handle if you have a hierarchical code list, so that if you've got a lot of detailed data which tells you the species of trees in particular patches of ground, and you want to generate a generalized data which just says, you know, this is woodland and this is not woodland, or even this is natural land cover and this is not, then that's hierarchical and in a sense quite simple. But as Robert said, the governance of the code list or of the hierarchy of types sits with the organization that's been publishing the data. So when you're using someone else's data, have they published the hierarchical assumptions behind their classifications? And if not, then that makes a problem because you're trying to derive a hierarchy out of someone else's data. But in a sense, it is about mapping concepts between different domains. And I think in these cases, it's achievable much of the time, but there are always in the world examples where it's not obvious and actually something isn't a true hierarchy. Right, yeah, there's a crossbreed between things. I mean, land cover and land use are both full of these things where something is one thing to somebody and a different thing to somebody else. There's interesting, Anthony's presentation brought us some insight into that from a very multilingual situation, and that shows up as, yes, even if you can agree among some domain experts what some concepts are, you then will have lots of different terms for those concepts in different flavors of English and in many other languages. But often that term, you know, isn't a complete match, and there isn't any neat mapping. But you know, it isn't intended to be a counsel of despair, whether it's code lists or other things. There are many occasions when a mapping which is good enough for the purpose can be made, which is where Rob's point comes in, that is governance. Somebody has to take the authority to make that decision and publish the results of that decision. and then other people can decide if they want to use that or not, or whether they prefer to go and invent their own mapping, which is where the mess comes back in. So I'm waffling a bit here, but I think that the call is for competent authorities, if you like, to make decisions and publish those decisions in usable ways. And that sometimes the competent authority is a very specialized small group, because nobody else really understands their world and their data about their world as well as they do. So coming back to the code list bit, I think for many cases, if we publish hierarchical code lists, which require different modeling or different serialization approaches to get that usable, then that can help people who are wanting to map, because they can go up and down the hierarchy until they find something they do understand and then map to that.
Rob, you want to comment?
Yeah, I think the species is a really good example. It's actually something I've done some work with, looking at citizen science and interoperability challenges. That's a really good example, because now there is a governance domain around species identification, and they have a very metadata-rich environment. But the group who publish species, and they have great web services, fantastic. But what they've done, of course, is they've done what everybody else has done. They've created an ad hoc interface, ad hoc encodings. It's idiosyncratic. And this is why I think that the interoperability of the mechanisms needs to be far better understood, tested, and promulgated, so that when a group like that does something, they don't just generate another solution. They actually become part of the solution, not part of the problem, because there is an obvious way of doing things. So I'm not sure that we yet reach the stage where we can go out to the world and say, here's the obvious way of publishing taxonomies so that you can reuse them. And we need to reach that point, in my opinion. And I'm really excited by this workshop, in that there's a lot more people starting to look about, yes, we need to think about standardizing taxonomies, both in terms of the terminology, both in terms of the nature of definitions, but I think the publication of definitions and the interoperability expectations, so that when people do it, they're not just reinventing the wheel. So, I mean, I think it's a really solid example, because as a group has been doing this for 30 years, why aren't they, why are we in a discourse with them about the standardized way of doing this?
Jen?
Thank you. Actually, that's a question for you, Rob. You just mentioned something that the terminology, the definition, and how to expose them to the public as such. But do you think that they should be done, this type of work should be done simultaneously, or do you think that we first should actually define and set out procedures how to coordinate and map the different terms and definitions so that they interact, and then when we have done that, we should start doing the exposure of the work?
I'm reluctant. I would be reluctant to separate them too much, because sometimes what happens if you want to support federation is that metadata requirements become evident, and if you're not feeding those into, right down to your tooling that supports the other processes, you end up with gaps in the process. So my feeling is that one of the reasons it's not solved is that we actually have to solve these problems simultaneously. And one of the big gaps is we haven't had a venue to discuss these issues moving forward, as Ronald says. I think we need to actually have something that goes beyond the ISO terminology mechanisms of looking at how ISO does terminology. We need to have a broader community group that is actually looking at publishing terminology systematically and consistently, and interoperability. I think this move towards fairness is a great opportunity. It gives people a conceptual handle on what needs to be done. But we need to get it to the stage where it's obviously working, and we can start retrofitting it to some of the sort of resources. For example, the species taxonomy. At some point, there should be a stage where it becomes obvious, or the money's available for them to retrofit an interoperable solution on top of what they're doing. So yeah, I think it's just a governance vacuum we have to deal with first. But we need to solve the problems. We need to bring all the stakeholders on the table and architect the solution so that we understand where the overlaps are. I think if we try to prematurely split it up, we end up with, yeah, inconsistent solutions that work in certain cases.
If I may just, Heidi, one more question in that context. Where do you see such an let's call it an organization, a group, a structure, be rooted? I mean, OGC, ISO, other could be having some, but do you see any particular place to play such an let's call it a setup?
You're still muted, Rob.
Sorry, I didn't realize there was a question about. I just put an answer in the chat. For me, this is a web architecture issue. It's about how resources are interoperable in a web context, irrespective of the domain. So it's not an OGC problem. It's not a ISO TC211 problem. It's broader than ISO because I know it comes to a whole range of activities which are not necessarily formal standards oriented either. So I think that having maybe activity inside the W3C, I mean, I'm in a thing called the Data Exchange Working Group, and I was very hopeful that we would get to this there, but it's been much more focused on basically the revision of DCAT and these broader issues of interoperable data exchange haven't really emerged. It's only data cataloging. So finding a home for it in W3C would seem to make sense to me.
Okay, thank you. Anthony Cooper?
Thank you. Species is a good example of governance problems. So the genus Acacia technically should apply to African plant species, but the Australians stole it because they want that they've got far more species in what was the previous acacia than there are in Africa. So the thing with governance is, and so this is more broadly, is that it can end up being with whoever shouts the loudest or has the most resources to impose their will and so
on. Alexander Shaman.
Thank you. Returning to Rob's last comment, in the IC we have a new type of systems committee, new type of technical committee. We call them systems committees. They work some kind of upstream in comparison of technical committees. And the question, how to say, where to discuss this architecture context, it should be, my understanding, the level of systems committee. For example, in Smart City, we discuss things, and what we found that if you want to use OJS excellent work, they have to align to our rules. They have to align to our understanding of smart cities, etc. So you see, it's we need to find proper context, and proper context that is a reference architecture of particular domain. For each domain or system domain which we use, Internet of Things, digital twins, smart cities, digital healthcare, it is necessary to develop reference architecture of this domain, and then we can guarantee interoperability of various concepts. Because currently we are moving bottom up. What is important is to add a top-down approach. And we started to do this on IC. We understood the bottom up is not enough. And at present, we just started to have some kind of common view among our technical committees. So I think we should, how to say, join this effort somehow. Thank you.
Thank you. Max, you're writing in the chat. Could you perhaps elaborate a bit on what you're writing and what you think would be a way forward? Ah, okay. Sorry. Anybody else who wants to comment? Perhaps if I may give a comment to something that was said before, it's on the concepts and on the code list. I'm wondering whether that isn't the same as what we wrote about in the chat before about the difference between concept models and data models. I'm thinking that, I mean, a cat is a cat, right? I mean, the 4 legs has a tail, says meow, and a cat is still a cat, whether or not we model it in a data model as a class, because we need more information about cats, as I don't know, the color could be anything, or whether it's in a context where we only need some kind of list of animals. So I'm wondering if that discussion on the code list isn't an example of that distinction that is important, that is often not made. And while I'm waiting for hands, let me give another comment I have, is that when in the Danish presentation, then at some point I said that, okay, let's not focus on technical stuff, because we can easily get into long discussions on URI patterns and other things that in the long run perhaps are details. I mean, just get a unique identifier and that's it. But I think it is indeed important, as Rob Atkinson's also said, it's not only about principles for definitions. It's really also about architecture. I mean, ET architecture. How we will make this work? There's so much information available. We need to publish it in a way that is maintainable, sustainable. So yeah, architecture and yeah, these days web architecture is really key. Rob, you want to comment on that, or is that an old hand?
Yeah, no, I just put a note in there, which is, yes, I think we can agree that conceptually cat is a cat. There are a whole bunch of philosophical issues about how you determine what a cat is and all that sort of stuff, and is a cat today the same as a cat tomorrow? And I agree that the class versus code list modeling of that is an implementation. So I think that's a good point. The challenge practically is we can't solve it from a top down by saying, oh, look, it doesn't matter. Because in reality, most of the concepts out there we're going to care about are the ones where data exists for it. And what we start with are their implementation models. Often what we have to do is work out how to take that data and pull it into a conceptual model. So we're often starting with the implementation models that people have, and then try to interpret the semantics of it. So we need to work backwards from the implementation models, and then start, do this process of back mapping them to a conceptual model, and analyze those, and are they the same or not? Look at data instances like the generalization topic. So given that we have to back engineer from those domains of discourse where the evidence is implementation models, we need to have a canonical way of describing the outputs of that back engineering. And I think that's one of the areas where that's very ad hoc at the moment. And if we could actually standardize that, if we had some canonical models for describing the relationships between conceptual models and implementation models, then I think that would be helpful. Exactly how useful it is, it's hard to know. There's a lot of work to be done. I mean, my feeling is it would be wonderful if there was an opportunity for a test bed where we could actually, develop some experiments and execute them, and see if we can get onto a common ground. And that sort of relates back to Max's point about NCOS. NCOS is a forum for discussion of these issues and around use of SCOS. That sounds great. The thing is, as a forum, it doesn't really have, it's currently an academic exercise. I guess the question is, how could we take that forum into something where organizations like W3C, ISO, the GBIF who maintain species lists, where all these various people who have operational requirements can actually, how do we convert an academic discussion forum into a governance forum for maintaining these essential glue pieces? We have work to do. We have to do it under some auspices. It's great that there are communities. It's great there's a lot of interest, but I just feel that we're still missing an effective coordination body for moving forward to agreeing on an architecture and starting to build it and test it.
Okay, thank you. That's really interesting. I was wondering, I'm really looking forward to hear other people's opinion on the need of this coordination body, as Rob said. I mean, do you have any experience? Do you have any national groups or other organizations that perhaps us that work in geospatial domain are not aware of? I would be really looking forward to hear more about that.
We could ask Joanna from IEC. Have you any kind of experience in that context?
Nothing jumps to mind, basically, immediately. I was just reflecting on it. I will reflect a bit more, and if something does come to mind, I'll let you know.
Thank you. I was also wondering, Larry, I know that you have been a liaison officer between ISO 22211 and a few organizations. Have you realized any of these issues or problems in your duty as liaison officer?
Larry, I'm not sure if you heard the question or still unmuted. They're still muted, sorry. Okay, I see there's a comment or question from Anthony, please.
Yeah, thanks. One problem, that we have, and I guess it might be in other countries and so on, is we get silos. So this is not about how to coordinate terminology and so on. This is a problem we have in that people work in silos and maybe deliberately, maybe accidentally, don't look to coordinate with other silos. So these could be, based on disciplines or professions or things like that, or they could be driven by politics. People trying to control some domain. Sorry, not much of a contribution, I guess.
It's okay, thanks a lot. So more opinions on the need of such a body or experiences with existing fora?
I noticed that Max and Jacob, you are having some discussion in the chat about SCOS. What is, I mean, SCOS is that the way I understand it at least, and you may correct me here, but the way I understand SCOS, that is a technical solution, solution. One of the, could be one of the technical solution for how to bring the various terms together. Is that correct understood?
Rob, please. Rob Atkinson?
This might be better if I'm unmuted. Yeah, so SCOS is a neat little technical solution for part of the problem, which is describing the relationship of labels to concepts and relationships between concepts and taxonomy hierarchies, and even a little bit of bundling these things together. That's great. What it doesn't do is it doesn't provide any guidance on how, for example, the relationship between implementation models and conceptual models might work. It doesn't provide any way of describing how you would map between, for example, animal of type cat and class of cat. So there's a whole bunch of things that it does well, and there's a whole bunch of things it doesn't do. So we need a architecture which pulls together a series of ontologies like SCOS that are neat and well modularized and well understood, and collectively solve the problems we're trying to solve. So yeah, I would endorse SCOS as a starting point, but it's not the entire solution.
Thanks. In Denmark, we have some colleagues, especially at the Agency of Digitization, that have been having a lot of thoughts on how to split data models from concepts models. I hope it's okay, Anna and Maya. Can I ask you to perhaps elaborate a bit on this and tell about the experience you have with this and difficulties encountered, or perhaps some kind of solutions for moving forward?
Yes, sure. Well, first of all, it's been really hugely interesting to learn about so many projects dealing with aspects of semantic interoperability, and if just to take back to the Stairway to Heaven that you showed, Heidi, in the beginning, it does seem to be generally agreed that it's hard. It will be hard. It's always be hard to harmonize, but somewhere in between, mapping seems to be the way forward. But referring to what we've been doing in Denmark, I think it's also very much like what both Alexander and Kita said about the decompositioning of models, so that basically conceptual models can also be basically decomposed and composed again of larger, more profiled glossaries or concept lists, so that they are treated in the same way, so that they can be applied in different contexts. But then very importantly, again, they are basically treated as a separate entity compared to data models, whereas Rob also commented that it has been, data models has been the way many people have started, also because when we do work in our organizations, speaking of silos, the approach has been more or less governed in projects in terms of application and systems, whereas we really need to take a more concept-oriented or domain-oriented approach, and then somehow put these together. But then again, yes, there are no other than the specific standards for each either SCOS or the technical solutions are there, but maybe not the how to join them is really important, which is also why I really think that somehow continuing these discussions in a more formalized way would be good. And it's been great to know that there are the NCOS I wasn't aware of either, but maybe W3C is a good way of meeting in a more broader context.
Thanks a lot. Yeah. Rob, is that a new hand or an old hand? Sorry, I have to ask. Okay.
Sorry, it's an old hand, but I'm an old hand, so if there's.
Yeah, thanks a lot. Yeah, really, really interesting thoughts. Yeah, on where to place that. On where to place that discussions. More opinions, more comments.
Well, I have one question, but actually pointing that's perhaps have been asked before. But Rob, you mentioned in your presentation that there was some problems with the relation between concepts. Do you have? I didn't quite understand if you also had a proposal for a solution for these kind of problems, but if there is, and could you please elaborate a little bit on that, because I think it could be worth.
Yeah, sure. I guess the answer is there's lots of relationships between types of things that I need to model and express as I try to make the OGC specification resources available, and particularly when I start linking them up. A lot of those expressions are, for example, how do I express the relationship between a conceptual model and an implementation of it? I mean, at the moment, I have to make something up because I can't find an ontology that describes that. So if I look at the T-box model, or the ontology driving my linked data environment, it consists of maybe a dozen different models, including SCOS and things, of which probably half of them are things which I've made up that I would rather have an interoperable solution for that other people use, because other people are going to need to say the same thing. And it doesn't make sense for OGC to govern a vocabulary describing these things. So I think it's not that it's impossible to model. It's just that there isn't an established best practice out there, and it means that anybody facing this, I mean, I've been doing this for years, and I'm gradually unpicking it, and it's a ridiculously large job to get started. And I think it's a barrier which is impossible for most people to contemplate, and it's certainly almost impossible to contemplate in a typical sort of project scope, the sort of timelines people have. So yeah, I think we can. That's why I've characterized it as a governance vacuum problem. We kind of know what we need to do, but not really who should be looking after these things. Does that make sense?
Yes.
Yes.
It does. Anthony Cooper.
Thanks. I guess once the concepts and terminology is encoded in SCOS or in SCOS extra large or SCOS extra large or whatever, that's the easy part, because then to correlate these different modeling domains with one another should be relatively straightforward. The really difficult part is to get the stuff into SCOS, and before that to actually identify the concepts and to create meaningful definitions of them. And then, of course, there's the multilingual problem.
Thank you.
Jan
Yeah.
Erik? I go back to the question whether a cat is a cat, and I can illustrate it by an example from the surveying domain. I've been teaching students working as a land surveyor, and we were able in our education to go into the field and discuss the boundaries and the ditches and what you see in the field. So this is my view of the cadastre. Now our Dutch colleagues who have prepared the land administration domain model, they are working in their offices and they are looking at the databases. And they also are concerned about boundaries. But this is the boundaries as recorded in the databases. And you describe boundaries in databases in a different way than you describe boundaries when you are walking around in the field. And this is one of the problems of terminology management, that you do not always describe the context in which these concepts are used. In Calate, we have different top concepts. We have one top concept concerning land, and this relates to the concepts which you have when you walk in the field. And we have another top concept, which is information, and which relates to the concept you have in the database. But it's difficult and not often seen that you bridge explicitly between different views of the same cat. Thank you very much.
Thank you. Heidi, I'm sorry interrupting, but I think we are running out of time. And I think if we let Alexander have the last comment, and then we have to close to move on so we can end by our scheduled time.
Okay, thank you. Thank you to Anna. She mentioned that we need to go, let's say, we need to have more standardization on higher levels, and also join with Eric's comment that context to define terms is provided by reference architecture. And actually exchange comments with Anna about its leg approach gives us good idea how to approach such kind of complex domain. Leg approach, it means there is some kind of common methodology to convert I would say pictures in our around us into set of fixed interoperable bricks. Remember that Lego started maybe with 30 different bricks, and right now several thousand, because people from the whole world, they propose their ideas using their toolkit. So what we need also to develop some kind of methodological toolkit to develop interoperable terminologies by design. Okay, thank you.
Thank you very much. And this was the last input from this very interesting discussion. And I think we have been covering lots of different aspects of this topic. So now I would like to give the word to Peter Paslow as the chair-elect for ISO TC211. If you could perhaps give us some of your personal or impression and thoughts attending this workshop as the chair-elect for TC211.
Yes, that's very challenging, but it is a challenge I accepted from Rees. But it's also worth, in the notes, I note Rees also has some things that he might like to say. And Rees, from the ISO TC211 perspective, has been the key person, I think, in making this happen. So I do want to say thank you to Rees and to Jan and to Heidi for organizing this. It's been very interesting. Briefly, I would summarize that there seem to be three levels of things. There's this discussion of what you might call philosophical approaches versus pragmatic approaches that was illustrated for us from geodesy, but it's there in other areas as well. And I think in TC211 we do need to get a bit more rigorous, particularly in things like distinguishing between concepts and logical models. So we'll be paying close attention to the discussions in the OGC architecture board around that. But actually often the ISO process leans much more towards that philosophical end than the pragmatic end. So it's a good lesson to, as Rob was saying, a lot of the time we're dealing with reverse engineering someone's understanding of the world out of the data they make available to us, rather than actually being able to find out what they really thought, let alone what the world is really like. So that's one level. And then the governance level, as Rob again has been saying, but so many others, that's about relationships. It's interesting, good to hear Anthony warn us that it shouldn't just be governance by the one who shouts loudest, but it is complex, as Rob says. It's got all those onion diagrams about different people being responsible, different organizations being responsible for different aspects of anything. But in that area, we see that there's the opportunity to be more confident in asserting what we as TC211 say about things in ways that enable other people to then use or criticize those things and tell us we're wrong. And that brings on to the technical publication stuff that we've been hearing bits about as well. So discussions of SCOS, URI patterns didn't get much mention, which is probably good, and even into software and servers. And I think there are groups of people from across this talk who will want to talk together more about learning lessons from each other on how to publish things. So it often gets a bit abstract, and I use words like things. So we've talked about how there are concepts. Concepts are described using terms. Terms vary even in the same language between different professional domains and in different languages. And there's opportunity for those terminology groups to relate to each other. Those opportunities open up more if the publication of the terminologies is in developer-friendly ways, I say. So it was interesting again to see Rob's many different sorts of user that we have to bear in mind, and it's not just to make our lives as publishers easier, but to make the lives of lots of different kinds of users easier, so we get a better result out of all this information. So hopefully that wasn't too waffly, but I want to give Reese also a quick opportunity to start, because Reese, you commented that you have some ideas about how we can take this forward.
Thank you, Peter. Yeah, thanks. On behalf of organizers here for the workshop, and of course all the participants and the presenters, really want to thank you all for 2 days of very exciting discussions and presentations. And I think that's really, it's been very eye-opening for those of us inside of the geospatial group there in TC211. We've learned a lot, and we're getting people from outside of the organization and those kind of things, and think that's important. And as I mentioned there in the chat, just a little bit to move this along and how we can go forward. So we've had some discussions and those kind of things, and I'd like to show you something that we have here, and if I can get that to come up. Hang on, please, just a second. Seems that it's not around here, so I'd like to show you something that a few of us who've been planning this workshop and also in some other discussions and groups have kind of been thinking about, and at least from the comments and discussions, we see some of this kind of echoed in what you've mentioned over the past couple days, is how do we move this discussion forward and where do we do that? And I'm not quite sure that this is going to be the right answer, but we think, those of us that have really had some ideas in planning this, that we'd like to have a deeper discussion on these subjects. And in order to move this forward and find a place where we can talk about those things, some of us have decided that maybe a new nonprofit organization would be a suitable forum to have these discussions and move them forward, not only for the geospatial domain, but for other domains. And having a new organization seems that that people from all domains could maybe come and participate and talk about these things and brainstorm, have ideas. So with a little bit of thinking about something for a name and those kind of things, we consulted some colleague that spoke Greek, and we came up with an interesting name here about possibly the name of this foundation that we had. And you can see that this is Enosema, which is derived from the Greek henosema, which means a true sign. And it has this intention of covering the meaning of insight and into semantics. So this is an insight into semantics. And we registered this foundation as a 501c3 nonprofit in the US, and have some people that are already working to make this, move it forward. And we want to facilitate the mutual understanding of these entities by providing insight and clarity to the concepts. We'll see what the foundation, it's open to a lot of new ideas. That's what we've been thinking about. And the foundation achieves these goals through contribution of domains of terminology, ontology, and semantics. So if learning more about this or talking about this is exciting or interested to you, so I'd like to hear from you, and you can contact me here. So it is an idea. Of course, it's not the only idea. It's not the only organization. And we'll have to see if this is successful or if it works. But if you're interested, I would like to communicate with you and talk about this. So, yeah. But on behalf of organizers from all of us there today who organized this and all the participants, I really want to thank you all. And Jan, I'll let you say a little bit more there.
Thank you very sorry. Thank you very much. Yes, we are about to close this workshop, and the plan is that we will distribute the presentations. We will communicate with you how this will be done, either via FTP site or a website, or where we just have to clarify a few things. And we will also distribute the list of participants, but we'll send you an email about that, because in Europe we have this GDPR issue with personal information. So we will send you an email about this, hopefully within the next few days, how much we can include in this distribution of list of participants. And with that, I think on behalf of the organizers, Ron, Heidi, and myself, I would thank you very much for attending the workshop on these 2 days. I was about to say over the week, but still 2 days. So thank you very much, and stay healthy, and hope to talk to you in a not too distant future. Thank you very much, and bye-bye.
Thank you, Jan. Thank you, everyone.
Bye.
Thank you very much. Thank you. Bye-bye.
Okay,
Bye
cheers.
bye.
Bye.
Bye, thanks.
Thank you.
Thanks a lot.
Jan, we'll have to think about how we